Buckle up. Here we go. 32 problems. This one's going to be a long one. Systems of equations pre-assessment. So when we have systems of equations, what we're talking about are two equations. They can be in linear form, y equals 2x plus 4, or they can be in standard form, 2x plus 3y equals 12. And as we know, there are an infinite number of solutions for this equation, and there are an infinite number of solutions for this equation. And because there are two variables, the solutions can be shown in coordinate form. So one way of finding the solution is, let's say that this is the solution to this equation, and let's say these are the solutions for this equation. So if we looked, this point would be a solution for both of those equations, and that would be the system, the solution to this system. And that's what we're looking for when we're given two equations, is we want to know where do they share a solution, and that would be the solution to the system. And that point, that green point, would be true for the blue line, and it would be true for the red line. So when we look for solutions, we can do it in a number of ways. One way that we can do it, that we'll work on first, is by graphing. So we like the fact that this first equation is in a form that we are familiar with. It is in slope-intercept form. So we can find the slope, which would be the coefficient of x, and we can find the y-intercept, which would be the constant. So I always like, well, let's do this so we can keep track of it. So we'll do the top equation in blue. So the slope of the blue equation would be 5 over 2. Which means it's rise over run, rise in the numerator, up, down, run in the denominator, left, right. So a positive 5 would mean up 5, and then a positive 2 in the denominator for the run would be to the right 2. So between points, we're always going to go up 5, right 2, up 5, right 2. But we don't have a starting point yet. So that's why we use the y-intercept. And the y-intercept in this equation is -3. It's the constant. Now we know it's in slope-intercept form because y is isolated. So we have our y-intercept, which is -3, and then we have our slope, which is up 5, 1, 2, 3, 4, 5, right 2 from that intercept. Slope is going to be the rate of change from one point to the next, and it's always going to be constant or consistent. So we can go up 5 again, 1, 2, 3, 4, 5, right 2, and that would take me to my other point. Now it's off the grid, but we should be able to calculate that coordinate. That coordinate would be 4, 7. 4, and then up 2 more, which would be 7. Now if we had to go down, if we had to find another point below it, instead of going up 5, right 2, we could also go down 5, left 2. Down 5, 1, 2, 3, 4, 5, and left 2 would take me to that point, and that coordinate would be -2, -6, 7, 8. -2, -8. So we can continue to use my slope in order to find points that are off the graph. So we're going to connect all those. That was almost perfect. And those need to have arrows because we know that there are an infinite number of solutions. So that's what that looks like. And now let's graph our other equation. Now let's do that in green. So we like the fact that it's isolated for y. So my slope for the green equation is going to be 1/2. Rise, +1 means up 1. Run, +2 means right 2. Now I don't have a location to go up 1 and right 2 yet. I got to find a point. And the point that we're going to pull is the y-intercept, which is 1. So I'm going to go to my y-intercept. It's where the line crosses the y-axis. And I'm going to go up 1, right 2. Up 1, right 2. Or down 1, left 2. Down 1, left 2. And I'm going to draw a line. Let's put arrows earlier. And here is my graph. Not even close to perfect. Not as good as the other one. Okay. And we see where that intersecting point. Intersection means that it's going to be the point that is true for both equations. And that point, obviously, is going to be this location. And what is that coordinate? That coordinate is going to be 2, 2. So that would be my solution to the system. So I'm going to write 2, 2, and I'm going to write it in parentheses because parentheses show a coordinate because we need an x and a y value. It's a solution to the equations. And since there's 2 variables, we need 2 solution, an x solution and a y solution. And we can plug those back into those equations to see if it worked. We plug 2 in for the top equation. If we plug 2 in for x, we get 5 minus 3. 5 minus 3 is 2. And we plug in the solution of my y, which is also 2, so 2 equals 2. If we did it for the green equation, plug in a 2, we get 1 plus 1 is going to be 2, and that equals my y value, which is 2. So that's what's going on with all this. And it's worth your time to plug it back in. If you want to make sure you are correct, take the time to plug it back in. All right, now we're going to work a little bit faster. So the slope equals 1/4, up 1, right 4. My y-intercept equals 3. I do my y-intercept. I go up 1, right 4, or down 1, left 4. I'm going to do my line. Looks like that. I have arrows. My slope for my other equation is going to be 3/2, which is up 3, right 2. My y-intercept this time is -2. Down here, I do my y-intercept, then I'm going to go up 3, 1, 2, 3, right 2, 1, 2, up 3, 1, 2, 3, right 2, takes me to there. I got my line, and I see where my intersecting point is going to be. And I think my intersection point is going to be 4, 4. I'm going to check it, and by checking, we'll just show the check for this one. We take the equation, y equals 1/4 x plus 3, and I'm plugging in these values. So I get 4 for my y value. That's my 4. That's my y value. Coordinates are written x, y. 1/4 times 4 plus 3. 1/4 times 4 is 1. 1 plus 3 is 4. And it worked for that equation. And I'm going to check my other. We have y equals 3/2 x minus 2. Y equals 3/2 x minus 2. I'm going to plug in 4 for my x. Whoops. I'm going to plug in 4 for my, I'm going to plug in 4 for my y. I'm going to plug in 4 for my x, and I get 4 equals, we're going to cross cancel. 3 times 2 is 6, minus 2 is 4, and we get a correct answer. So I know that that solution worked. So when I tell you to check, you're plugging it back in, and you're making sure that the left side simplifies and is equal to the right side simplified. We're not moving things around. We're not isolating and moving things across the equation. We're plugging in, simplifying the left side, simplifying the right side, making sure that both of those sides are equal to each other. So that is correct answer. Slope is -7/2. Notice that negative was in the middle. So I'm going to choose to either put it in the numerator or I'm going to choose to put it in the denominator. If I choose to put it in the numerator, that is going to be rise -7. So negative is down 7. Run 2 is right 2. Or if I had placed the negative in the denominator, that's going to be up 7. And this is going to be left 2. It will take you to the same place. My y-intercept is going to be 4. So I do 4. Now I'm going to go down 7 because if I went up 7, I'd be way off this graph, which is still fine, but it's going to make it a little bit more challenging. So I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7, and right 2. And let's connect them. It's going to be a little rough. That's why it's important to check. That's why we don't like graphing as much as we like substitution or elimination, addition, multiplication. That's good. Let's do my other equation. My other equation has a slope of -1/2. That's going to be either -1/2, which is down 1, right 2, or 1/-2, which is up 1, left 2. I can choose whichever one, and then whichever one makes it easier to intersect with the blue line. My y-intercept to my green equation is going to be -2. So -2. And let's go up. Let's use the other one. Let's go up 1, left 2. Ooh, up 1, left 2 maybe does not work because now we're moving away from my equation, from my blue line. So I'm going to use the down 1, right 2. Yes, down 1, right 2. That was a whole lot better. So you see, hopefully you see what I'm doing there and trying to find the point that is intersecting my other system. Oh, look at that. That's nice. So I see that it's intersecting there. Did I highlight? No, I did not highlight. I think I did in the first one. Yes, I did. So let's highlight that coordinate or that location. Looks like 2, -3. 2, -3. Quickly, I'm going to do mental math. So does -3 equal -7/2 times 2? That's -7 plus 4 is -3. That worked. And then the bottom equation, does -3 equal -1/2/2 times 2, which gives me -1 minus 2 is -3. So that worked with my check. My slope equals 1/3, which is up 1, right 3. My y-intercept is 3. I have my other equation, which has a slope of -2, which is -2/1, which is down 2, right 1, with a y-intercept of -4. So let's graph those. Y-intercept of 3, up 1, right 3, or down 1, left 3. Let's make those lines blue. Lots of, that's pretty good. Let's graph my other one, -4 y-intercept, down 2. Okay, well that's going to take me off the graph and I'm moving away, so I'm going to actually go up 2 and left 1, up 2, left 1, up 2, left 1, up 2, left 1. So it took me a little while, but it worked out. Let's graph those, that line, and it looks like my intersecting point is right there. And I think that that coordinate is -3, 2. -3 on the x, +2 on the y. And we plug it in. Does 2 equal 1/3 times -3, which gives me -1, plus 3 is 2. Does 2 equal -2 times -3 minus 4? -2 times -3 is +6, minus 4 is +2. So that checked out. Now, number 5 is not in standard form, or is not in slope-intercept form. It is in standard form. So standard form, I'm going to find the x and y intercepts by using the cover-up method. So let's take the first equation, and I'm going to cover up the y value and its coefficient, -2y. I'm going to cover that up, and that leaves me with x equals -6. So I know my x-intercept is -6. And then when I want to find the y-intercept, I'm going to cover up the x and its coefficient, because I'm plugging in 0 for the y-intercept, 0 in for x for my y-intercept, which leaves me with -2y equals -6. And if I solve for y, that gives me a +3. So I have an x-intercept of -6. Make sure you go on the x-axis. And I have a y-intercept of +3. So on the y-axis, I'm going to connect those. It's not the best example that I could have chosen because it is off of the graph, but it's all right. Let's check it out. This is real world stuff, and that was not the best graph. Connecting of the dots, okay. Now let's do the the other equation. So we'll use the cover-up method. We'll cover up the y and its -1 coefficient. So that leaves me with 4x equals 4. So my x-intercept is 1. And then when we cover up the, x-intercept equals 1. And then when we want to find the y-intercept, we cover up the x and its coefficient, 4. So that leaves us with -y equals 4. We'll solve for y by dividing both sides by -1, and we get my y-intercept is -4. So x-intercept on the x-axis is 1, y-intercept on the y-axis is 4. We're going to connect those. And that kind of looks like it goes there. Now, we know that from point to point is our slope. So I can utilize this and see. So if I go from this point, to this point, what would the slope be? What would the slope be as I go up 1, 2, 3, 4, right 1? So if I keep going up 1, 2, 3, 4, right 1, it takes me there. And that's the same thing for the blue. I can still use the slope. I go up 1, right 1, 2, 3. Sorry, Mr. Mac, that is so dumb. That was not what I did. I gotta go up 1, 2, 3, right 1, 2, 3, 4, 5, 6. So does that still, that's good, up 3. Oh, that's up, yeah, Mr. Mac, up 3, 1, 2, 3, right, 1, 2, 3, 4, 5, 6. It got me to that point, but that's not the intersecting point. So that didn't really, an intersecting point looks like it's there, 2, 4. So we will plug it in. For my x is 2. So our equation is a little bit different, a little different format. So when we have x minus 2y equals 6, negative 6, excuse me, I'm plugging in my x value, which is 2. My y value is 4. And I get 2 minus 8 equals negative 6. 2 minus 8 is negative 6 equals negative 6. So it worked for the first equation. And then I have 4x minus y equals 4. So 4 times 2 minus my y value. 8 minus 4 equals 4. 8 minus 4 is 4. Does 4 equal 4? Yes. So it worked for both of them. So I know 2, 4 is my solution. Let's do the first equation. We have an x-intercept of negative 4. We have a y-intercept of positive 4. X-intercept, y-intercept. Connect those lines. Oh, that was really bad. I started way off the graph. Good. Let's do my other equation. My x-intercept. Ooh, look at this one. Negative 1/4. My y-intercept is going to be negative 1. So x-intercept negative 1/4. That's not very accurate. I'm just sort of eyeballing it. Is that where negative 1/4 is? Sure. I mean, it's somewhere between here and half. And then my y-intercept is negative 1. So here, oh baby, look at that. Okay. Again, probably not the best second problem to choose from, Mr. McCausland. But let's play. Let's go. Let's do it. All right. That doesn't look like it's intersecting somewhere. So did Mr. McCausland do something wrong? So we've come to the point where it looks like it might be wrong. I'm checking, going through back and checking my work. So I have an x-intercept. I am confident it's negative 4. And there's my mistake. How many people saw that? It's good that I make mistakes. It's very good that I make mistakes because my x-intercept is negative 4, my y-intercept is positive 4. When it doesn't make sense, stop and check your work. Check and see. Stop. Redo your work. Now this makes a little bit more sense, does it not? Yes, it does. Okay, now it looks okay. I'm just going to check my intercepts. Negative. I did my x in the right place this time. So the problem was I put my x-intercept as a positive 4, not a negative 4 initially. I've fixed it, and I see where I think my solution is now. I think my solution is going to be right there. I think that's going to be a little bit, well, I think that's going to be a little bit better, more accurate. So let's test it. Best thing to always do is test it. I think that my solution is going to be negative 1, 3. So plug it in. Negative 1 minus 3 equals negative 4. 4 times negative 1 is negative 4 plus 3. Negative 4 plus 3 is negative 1, and it works. Always good to make mistakes because you learn and you see where people tend to make their mistakes, even the teacher. So my x-intercept, remember, x-intercepts y equals 0. So if we plug in 0, we're left with 2x equals 2. Solve for x, we get an x-intercept of 1. Y-intercept, remember, we're plugging 0 in for y, 0 for x. We plug in 0 for x for our top equation. We get negative y equals 2. Solve for y gives me negative 2. My x-intercept is on 1, positive 1. That's on the right side, Mr. McCausland. Y-intercept is negative 2. That would be down here. This one, I'm certain I I did it correctly. And yes, you saw that. I forgot to hit that one. And we're good to go there. At least relatively certain until we check. My other equation, my x-intercept, is going to be 6. Intercept equals 6. My y-intercept equals 3. X-intercept 6. X-axis 6 over here. Y-intercept 3. Y-axis there. That looks pretty good. Oh, that was nice. All right, so let's do this. Oh, that was very good. That was a good one. So we're gonna have that as my solution, as my attempted solution, which is 2, 2. I'm going to check it. 4 minus 2 is 2. 2 plus 2 times 2 is 4. 2 plus 4 is 6. Yep, that worked. Oh, I like this one. So this is the situation where we're given lines in 2 different forms. We can see this as in, no, let's not do it green. We can see this equation as in slope-intercept form. So my slope is 0, which is 0 over 1, which is up 0, right 1, and my y-intercept is going to equal 4. Or we can see that there's only one variable. When there's one variable, we know it's either vertical or horizontal. And what we do know is the variable that we see and the number, y equals 4, so we know that it goes through the y-axis at 4. So it would give us that line. Now, again, if we looked at it in slope-intercept form, we'd make a dot at 4, and we'd have a slope of 0, which is up 0, right 1, up 0, right 1. So it would have still created that same line. We go to my other equation, which is in standard form. So we're going to go back to the x-intercept. The x-intercept, we're going to plug 0 in for y. That leaves us with 8x equals negative 4. Solve for x. Divide both sides by 8. We get negative 1/2. My y-intercept, plug 0 in for x. Leaves us with y equals negative 4, is negative 4. So my x-intercept, I'm going to go to the proper x-intercept. Y-intercept is negative 4. I'm going to go to the proper, and then we're going to draw a line. And this really shows why graphing is not the best, because it's not very accurate. It's kind of off, and it depends on your graphing skills. It depends on whether that intersection is at a grid line. So it looks like the grid, it looks like the intersection is going to be at negative 1, 4. So my supposed solution is negative 1, 4, and then we can plug it in. Well, if we plug negative 1 in for x to this equation, we don't see an x. So we have to remember that this equation can be thought of as this. We don't see an x because the coefficient of x is 0. So if we plug that negative 1 in here, 0 times negative 1 is still 0. And then y equals 4. Does 4 equal 4? Yeah. So it checks with that top equation. And then we plug it into the other equation. We get x times -1. X 8 times -1 is -8. Plus 4 gives us -4. So when we checked, it still worked. All right. This top one is in standard form. So I'm going to use the cover-up method. My x-intercept gives me 8x equals -12. Divide both sides by by 8, and I get x equals -12 eighths. -12 eighths. We should always reduce that. That gives me -3 halves. And then my y-intercept, plugging 0 in for x, gives me a +2. Y-intercept, y-axis, 2. X-intercept, -3 halves is -1 1/2. That's all right. That wasn't too crazy. That was manageable. So that's somewhat good. I'm off by a little bit, I think. And now we look at this other equation. So this is where the real work comes, is you have this equation 0 equals x minus 3 minus 3y. So you got to decide, how do I want to rearrange this? Do I want to put it in slope-intercept form? Or do I want to put it in standard form? You decide, which one are you most comfortable with. So if you put it in slope-intercept form, you have to isolate for y. So I'm going to add 3y to both sides. I get 3y equals x minus 3. I'm going to divide everything by 3. And I get y equals 1/3 x minus 1. So my slope is 1/3. My y-intercept equals -1. So y-intercept of -1, slope of 1/3, up 1. Did I really do that? Oh, up 1, right 3, up 1, right 3. That's taking me further. Down 1, left 3. Down 1, left 3. So that worked out. We will also do standard form if we did standard form. So that's a horrible graphic. There you go. That's much better. All right, let's do standard form. So what if we wanted to do it in standard form? So standard form, we start off with the equation 0 equals x minus 3 minus 3y. So I'm going to subtract x from both sides. I get -x equals -3 minus 3y. I'm going to add 3y to both sides. And I get -x plus 3y equals -3. So my x-intercept is going to equal a +3. Plug 0 in for y. Cover up the 3y. Leaves me with -x equals -3. Divide both sides by -1. And my y-intercept is going to be -1. So my x-intercept is 3, which is this point right here. My y-intercept is -1, which is right here. And I would have connected those and still come up with the same solution to the system. And that solution is going to be -3, -2. Let's go back and make sure. 8 times -3 is -24. -6 times -2 is +12. 36, -36 plus 12 gives me, no, 24. Sorry, did I say 36? 8 times -3 is -24. Plus 12 is -12. That works. Let's plug it into the bottom equation. And the reason why I got it wrong right there with the 36 is because I'm doing it in my head again. I'm not writing it down. Write it down, students. Let's check the bottom equation, the green one. 0 equals -3 minus 3, which is -6, minus 3 times -2. -3 times -2 is +6. -6 plus 6 gives me 0. So it worked. All right, here we go again. We have a single variable, but the big trick here is it doesn't say x equals, it says -x. So if I looked and saw that there was only one variable, I got to also make sure that that variable is isolated. So we have to convert that. We have a little work to do. And it says x is 3. Where does it cross the x-axis at 3? Looks like that. And now my other equation also looks like it's in slope-intercept form, but let's change that to blue. Let's change that to blue. My other equation also needs to be fixed a little bit. It looks like it's in slope-intercept form, and it's not in standard form, or in this, not in standard form, in slope-intercept form, which is the variable x before the constant. And now I'm going to divide everything by -1, and we get y equals x plus 1. So my slope equals 1, which is up 1, right 1. My y-intercept is also 1. My y-intercept up 1, right 1, up 1, right 1, up 1, right 1, and I eventually got to my intersecting point. That's pretty good. I think my solution is going to be right here, and that point is considered 3, 4. If I plug it, if I plug in 3 for x, that gives me -3. So -3 equals -3. If I plug into the bottom equation, I get the opposite of y, which is -4 equals -1 minus 3, which is -4. So it checks correctly. All right, that was graphing. Now we're going to use the substitution. So when we don't graph, we have 2 equations, and those equations have 2 variables. This has 2 variables, so we can't isolate. Well, you notice that we isolated for this, and we have it in terms of x. So even when we solve for y, we don't get a constant. So we don't know what y is because it's in terms of the other variable. And if we look over here, if we isolated for one of those variables, the y value or the x value would be on the other side. So when we have 2 variables, we can't figure out what it's equal to. So we're going to use the substitution method. Our goal in using the substitution method is if we isolate for one variable, and then we take that and substitute it back into the other equation. So if we write this bottom equation, -2x minus 2, instead of writing y, we know that y equals this. So we're going to substitute what y equals, because y equals 5x minus 24. And then we're going to write the rest of the bottom equation. Hopefully that makes sense to you. And you'll see why it makes sense, because now if we look at our new equation, what do we notice? We only have x's. And since we only have one variable, if we simplify and isolate, we're gonna find out what that value is. So we have to simplify first. We have -2x, and then we have -2 times 5x, which is -10x. And we have -2 times -24, which is +48, equals 0. Let's simplify. We have like terms on the same side of the equal sign. That gives me -12x plus 48 equals 0. Now we're going to isolate. This is a two-step equation. We're going to divide by negative 12, and we get x equals positive 4. Now we're going to take the other equation, since we plugged in, we substituted into this one, we are going to, once we found that x value right here, we're going to substitute it back in to the top equation. Oh, did you see that? That was almost a problem. That's right. So we're going to take that top equation, y equals 5x minus 24. We're going to take this value for x equals 4, and we're going to plug it in to the top equation. We get y equals 20 minus 24, y equals negative 4. So we have been able to write it as a coordinate. Do not use solution sets. If you write a solution set, I'm going to minus it off. If you don't write it as a coordinate, I'm going to minus it off. So be aware, you've been warned. All right, this time the bottom equation is isolated. We know that we're going to use the substitution when we have an equation that is isolated in terms of the other variable. So I'm going to take this and I'm going to plug it into the y value in the other equation. So 4x minus, instead of writing y, we're going to write 5x minus 17 equals 10. So 4x minus 2, substitute the y value, equals 10. We're just rewriting everything up there. Okay? All we're doing is rewriting and substituting that value. Now we're going to simplify. Simplify before you start moving things. Negative 2 times 5x is negative 10x. Negative 2 times negative 17 is positive 34 equals 10. Let's simplify. Don't start moving things. They're on the same side of the equal sign, so I have 4x minus 10x, which gives me negative 6x. Now we can do the two-step. Negative 6x gives me negative 24. Divide by negative 6, and I get x equals positive 4. Oh, I forgot to check. Mr. Mac, yeah, we should probably check 4 and negative 4. So does negative 4 equal 5 times 4? Yep, that's 20 minus 24 is negative 4. Let's do 4 times negative 2 is negative 8. And negative 2 times negative 4 is positive 8. That equals 0. Sorry. I just remembered that we should check. Okay. So we substituted back into here to find my x value. So we're going to go into the other equation to find my y value. My x value is 4 minus 17. Y equals 20 minus 17. Y equals 3. So make sure you write your coordinate, your x value, your y value. 4, 3. 4 times 4 is 16, minus 2 times 3 is 6. 16 minus 6 is 10. Does 3 equal 5 times 4, 20 minus 17? Yes, because that's how we got that bottom one. All right, that's good. We've got a variable isolated. That tells me I'm going to use substitution, and I'm going to substitute it into the other equation. Negative 6x plus 4. Instead of writing y, we're going to write negative 8x plus 22. And we're going to write the rest of the top equation. Negative 6x. Let's distribute this 4 into the parentheses. That's negative 32. That's positive 88 equals 12. Let's simplify. Oh, Mr. Mac forgot to write an x. Positive 4 times negative 8x. And look, notice each time I make a mistake, my brain says, hold on. Typically, we have two variables that we have to add right here. And we didn't, and I was about to add two constants. And I knew that was weird. Hey, that was different. So check yourself. Notice, what are the patterns? Why is this different? Is it different because I made a mistake, or is it different because the problem is different? So slow down, don't rush through it. Make sure you check your work. Make sure you're thinking about what you're doing. Like Mr. Mac. So negative 38x plus 88 equals 12. Let's subtract 88. Negative 38x equals, so when we have signs are different, we're going to take the smaller from the bigger. That gives me 6, that gives me 7, and I have more negatives than positives. I'm going to divide by negative 38, and divide by negative 38, and I get x equals, all right, 76 and 38. Well, that's actually 2. 38 and 38 makes 76. So my x value is 2. I'm going to go back, plug it back into here. 2 plus 22, y equals negative 16 plus 22, y equals 6. So my solution is 2, 6. Let's check it real quick. So negative 6 times 2 is negative 12. Negative 12 plus 24 is 12. And does 6 equal negative 8 times 2 is 16 plus 22 is going to give me 6. Good. All right. Oh, hello. So it says that I have to use the substitution method. Which method would I like to use? Yeah, I'd like to use the addition method. But because it said you must use the substitution, I'm going to have to rearrange. I got to rearrange because I must use the substitution method. So I'm going to take this top equation because this looks like the easiest to rearrange. I'm going to solve for y because when we use the substitution, you want to solve for a variable in terms of the other variable. So I solve for y in terms of x. And I'm going to take this and I'm going to plug it in to the other equation. Ooh, I like this other equation because there's something tricky about this. My other equation is this. So when I plug in this y value, it says negative x minus the y. So that negative has to be distributed into the value of x, or what y equals. So I have to distribute that negative 1. This can be a tricky one. Most students will probably come back and see that you got this one wrong. 4x minus 2 equals negative 6. Add 2, add 2. 4x equals negative 4. Divide by 4, x equals negative 1. Mr. Mac, why didn't we just use the addition method? Well, if you had the option of doing any technique or any method, you would definitely choose the addition method. But because I want you to deal with it in the difficult situations, you needed to use the substitution. So I'm going to check and make sure that you use the substitution method and rearranged. That is going to be a contingency. You will have to do that, even though it looks like you'd rather use addition. So x is negative 1. Y equals 5 plus 2. Y equals 7. So I think my solution is negative 1, 7. Negative 1 into negative x gives me positive 1. Positive 1 minus 7 is negative 6. That worked. Negative 1 for x. Let's do the top equation. That's negative 5 plus 7 is positive 2. That worked. Another one where we're going to have to rearrange. So which equation, which variable in which equation would I want to isolate? Because when we use the substitution, we want to solve for one of the variables. Well, it's quite obvious. I'm going to solve for that variable in the top equation. So when I rearrange, I'm going to make this equation y equals positive 8x plus 13. Hopefully you saw how we got that. We have negative 8x plus y equals 13. I want to isolate for y, so I got to get rid of this negative 8x by adding 8x. And that gives me y equals 8x plus 13. Now I'm going to take this y value, and it's equivalent to 8x plus 13, and I'm going to plug it in for this y. So this part is going to go in for the y, and it says 5 times that y value. So I have to distribute y into it. So that gives me 3x plus 5 times the quantity, 8x plus 13 equals 22. 3x plus 40x plus, what's that, 65 equals 22. 43x plus 65 equals 22 minus 65. 43x equals, I can't take 65 from 22. I can't take a bigger from a smaller. So since the signs are different, I'm going to take the difference of these, and I have more negatives. So I got negative 43 divided by 43. X equals negative 1. Did I write a coordinate for my solution on that one? Yes, I did. And I'm going to plug it back in. So I have x equals negative 1. So we have y equals 8 times negative 1 plus 13, which is negative 8 plus 13, which gives me 5, positive 5. So my coordinate, my solution to the system is negative 1, 5. Negative 1, 5. Plug in negative 1 gives me positive 8. And positive 5 gives me 13. Plug in negative 1 in the bottom equation gives me negative 3 plus 25 gives me 22. That worked. Which variable I'm going to solve for? I'm going to isolate for y. So that new equation is y equals 6x minus 11. I'm going to plug this in for my y. So I get negative 6x minus 3 times that quantity. 6x minus 11 equals negative 15. Negative 6x minus 18x plus 33. Don't forget to distribute to both items. Negative 6x, negative 18x gives me negative 24. 6, 12, 13, 14, yep, plus 33 equals negative 15. Let's subtract 33. Gives me negative 24x equals negative 48. Divide by negative 24. X equals positive 2. Let's go back to this equation because it's set equal to. We're looking for y, and we know that x equals 2, y equals 12 minus 11, y equals 1. So my solution is 2, 1. Check it. 2 is negative 12, and 1 is negative 11. 2 is negative 12, minus 3 is negative 15. That's how quickly we can do it. This is a good one. So we notice that both of our variables are solved for y. So we can make the assumption that y equals y. Well, let's use two different colors there so we know which one we're dealing with. So y equals y. We know that. So we can set them equal to each other. So I'm going to take that, and y equals 6x minus 16, and y also equals 8x minus 22. So I'm going to take that first one, 6x minus 16 equals the other one, 8x minus 22. Let's move the variables first. Negative 16 equals 2x minus 22, add 22. Move my constants to the other side. I get 6 equals 2x. Divide by 2, 3 equals x. And now I can pick any of the top equations. Let's pick the top one, y equals 6x minus 16. And my x value was 3. So 6 times 3 minus 16. Y equals 18 minus 16. Y equals 2. And my solution is going to be 3, 2. Go back up, plug 3. 6 times 3 is 18. Minus 16 is 2. Let's do the bottom equation. 8 times 3 is 24. Minus 2 is 2. That worked. Again, we have the same situation. Both of them are isolated for a variable, and they happen to be the same variable, so we can set them equal to each other. X plus 3 equals 3x plus 15. Let's move the x's over there. 3 equals 2x plus 15. Subtract the 15. We get negative 12 equals 2x. Divide by 2. Negative 6 equals x. Plug it in. Let's do the bottom equation this time. And my x value was negative 6, I think it was. Negative 6. 3 times negative 6 plus 15. 3 times negative 6 is negative 18. Y equals negative 3. So we got a solution of negative 6, negative 3. Let's plug it into the top equation. Does negative 3 equal negative 6 plus 3? Yes, it does. So we did those problems pretty quickly. And you have to be efficient. That's the whole key to this, is being efficient with your work and being efficient but not making silly mistakes. Or if you do make a mistake, are you able to catch them? So each time we were able to isolate, we were able to get rid of one of the variables. Our issue with the starting problems is that we have two variables in both of the equations. But when we use the substitution method, notice we ended up with one variable. So substitution is one way. Another way is through the addition. And we're going to add the two equations together. So the first thing whenever you add them is they need to have the same, they need to be in the same order. Same order. Both equations need to be in the same order. So this is x, y equals constant. X, y equals constant. So those are aligned. And when they're aligned and we're using the addition method, we're going to add those columns. So we're going to add the like terms. We're going to add them together. We're going to combine them. And then we're going to tally them up. So 6x and negative 6x makes 0. 3y and negative 8y gives me negative 5y. And 12 and 0 gives me 12 and 0. 12 and negative 12 gives me 0. Now we're going to, the nice thing about this is, how many variables do we have? We only have one variable. That's nice. Here we had 2, here we had 2. So that's why we can't do that. And we wouldn't use substitution because neither of these equations is isolated for a variable. So it's not conducive to using substitution. It's conducive for using addition, because one of these variables is the opposite. The coefficients are opposite. You have 6 and -6 for the coefficients. So we know that they're going to cancel. Leaves us with just the y value. Divide by -5, and you get y equals 0. Now we're going to pick one of those equations. Doesn't matter. I'm going to pick the top one. 6x plus 3y equals 12. And I'm going to take that value, I'm going to substitute it in. So y equals 0. 6x plus 0 equals 12. 6x plus 0 is 6x. Divide by 6, and I get x equals 2. So my solution to my system is going to be 2, 0. I know it works for the top one. I'm going to check with the bottom one. -6 times 2 is -12. -8 times 0 is 0. Does -12 equal -12? Yes, it does. So that worked. Is this conducive to addition? Why? Because the y's cancel. The coefficients are opposite of each other, -7 and +7. So when I add them together, I'm going to be left with one variable. When I'm left with one variable, I can solve for it. And I can get a solution. X equals 3. And now I'm going to take one of those equations. Let's take the top one this time. I'm going to plug in my x value. 21 minus 7y equals 14 minus 21. I'm solving for y now. I'm going to divide by -7, and I get y equals 1. So my solution to my system would be 3, 1. So I used the top one, so let's check with the bottom one. X equals 3. 3 plus 7 times 1 is 7. 3 plus 7 is 10. Does it equal the right side of that equation? Does 10 equal 10? Yes, it does. All right, so find out which one cancels. I see my y's cancel again. Positive 8y, negative 8y. I like that. That would lead me to use the elimination or the addition, which eliminates, it's called elimination because it eliminates one of the variables. We get -4x equals 24. We're adding the columns up. -9x and +5x gives me -4x. 22 and 2 gives me 24. We'll divide by -4. We get x equals -6. That's an ugly x. Let's pick an equation. Let's use the bottom one this time. It doesn't matter which one you use. 5 times -6 minus 8y equals 2. That's -30. Minus 8y equals 2. Add 30. -8y equals 32. Yes, I know many of you saw that was -4. But let's show the work. Show it. So if we do, even the teacher makes a mistake, he can go back and look at his work. That's why I'm able to catch my mistakes, because I have work to go back and refer to. Let's check the top equation. -9 times -6 gives me +54. 8 times -4 is -32. 54 and 32 gives me 22, and it equals that. That worked out. That was my check. Okay. Which variable cancels? If they do, yep, that did. That's nice. So those are going to cancel out. I have -6y and +2y, which is -4y. -6 and 2 gives me -4. Divide both sides by -4. Y equals 1. Pick an equation. Take the top one. Plug in for the y value. 8x minus 6 equals -6 plus 6 plus 6. 8x equals 0. Divide by 8. X equals 0. did that problem almost less than a minute. So we can get through these 32 problems relatively fast. It should not take you over an hour to do 32 problems. If it is, then you need to do more in order to make sure that you are working efficiently and you're familiar with it and you can recognize the trick problems. You can recognize the simple problems. These are simple. They haven't gotten hard yet. There's a couple hard ones coming up. Let's check our answer. We plugged it into, we solved for the top equation, so we'll plug it back into the bottom equation. Negative 8 times 0 plus 2 times 1 gives you 2. Ooh, alrighty. So, this is good, but we still have to rearrange. That's not how you spell arrange. Rearrange. So my top equation is x, y, constant equals 0. So I have to make sure that this is in x, y, constant equals 0. My constant doesn't have to be on the right side. Everything can be on the left side. It's just that they have to align with each other. So when I add them, add the columns, I'm adding like terms. X's with X's, Y's with Y's, constants with constants, and my other constant with a constant. Those don't have to equal 0. That just is happenstance. So 8x, 4x gives me 12x. Positive 4y, negative 4y gives me 0. 16 and negative 28. 28, 16 signs are different, so we're going to take the difference. Gives me 12. I have more negatives. 0 and 0 gives me 0. This is a two-step equation. Let's add 12 to both sides. 12x equals 12. Divide by 12. Divide by 12. X equals 1. Pick either equation. I'm going to pick the top one. I'm going to plug in 1 for x into that equation, which eliminates one of the variables, leaves me with just one variable, y. I'm going to simplify the left side before I start moving things. 24, and now it's a two-step equation. Subtract 24, divide by 4, y equals negative 6. So my solution is 1, negative 6. Where am I going to write that? 1, negative 6. I plugged into the bottom equation, so I'm going to test with the top. 8 times 1 is 8. 4 times negative 6 is negative 24. 8 and negative 24 gives me negative 16. Negative 16 and positive 16 is 0. So that worked. All right. So yes, you may want to use substitution here because you're kind of close. You would multiply everything by negative 1. But remember, we're using the elimination or the addition. So I have to use the addition. So let's rearrange. I have an x over here, but in this equation I have x over here. So I'm going to rearrange this equation. I'm going to get my y equals my constant and my x value. So I have negative x equals negative 4y minus 7. So I'm going to have to move two things. I have to move this y over there and the x over here. My constant's in the right place. And I'm going to make sure that they're in the same order. I have x, oh no, sorry. I have y constant x. So I'm going to add x to both sides. That gives me 0 equals negative 4y minus 7 plus x. I'm going to add the 4y to both sides. So I have 4y equals negative 7 plus x. And that is in the same order as that bottom equation. Y equals constant and my x value. So I'm going to rewrite that one. underneath it, negative 10y equals 7 minus x. And I'm going to combine them. Now I can use the addition method. I'm going to add my columns. What do I get when I add my columns? I get negative 6y equals, oop, did I make a mistake? I did not make a mistake. I thought I maybe made a mistake, and I checked because I have negative 7 and positive 7. They cancel, and that's kind of important. So that's 0, and then I get positive x and minus x, which is 0. Oh, this is a good tricky one, which is fine. But it was weird, so I went back and took my time and checked. So my y value is 0. I'm going to pick one of these equations. I'm going to pick, let's pick the top one. I know it's harder or more uncomfortable. We get negative x equals negative 4 times 0 minus 7. Negative x is 0 minus 7. Negative x equals negative 7. I'm going to divide by negative 1. X equals 7. So I think my solution is 7, 0. 7, 0. So let's check. We're not going to check the top equation. We're going to check with the bottom one. So negative 10 times 0, and 7 minus 7 is 0. So 0 equals 0. I'm correct. All right. Now, this is good. Both of the equations are aligned properly. We have x's, we have y's equal constant. But what do we notice? We notice that none of the coefficients for the variables are opposite of each other. That's negative 3 and negative 10. Those don't cancel. This is negative 10 and negative 20. Those don't cancel. All right, so we know that we can multiply. We can find equivalent equations. Two things. We're familiar with equivalent fractions. These are equivalent fractions because we multiplied the numerator and denominator by 5. We multiplied everything by the same number. 1 times 5 is 5. 2 times 5 is 10. So we know that these are equivalent fractions. And when you multiply everything by the same number, it gives us equivalencies. So we're going to use that concept. So what do I want to, I'm kind of close, right, with my y's? I'm kind of close because 10 and 20 are multiples. 20 is a multiple of 10. So now, notice my signs are the same. They need to be opposite. They need to cancel each other. So what do I multiply negative 10? Well, I want to get rid of the negative 20y. What's going to get rid of a negative 20y is a positive 20y. So what can I multiply by negative 10 to make it positive 20? I multiply by a negative 2. So I need to multiply, if I'm going to make it an equivalent equation, I need to multiply everything by negative 2. So negative 2 times negative 3x gives me positive 6x. Negative 2 times negative 10y gives me positive 20y. That was what I was shooting for. And negative 2 times positive 17 is negative 34. And then I'm just going to rewrite this equation. I'm not going to manipulate that equation or write an equivalent equation to it, because we see that my y's cancel. This is good. Now we can use the addition method because my coefficients of my y's are opposite of each other. So we have 6x, negative 10x is negative 4x. My y's cancel. Negative 34, positive 30 gives me negative 4. Divide both sides by negative 4. X equals 1. Take either one. You can take either the original. You can even take the equivalent equation. We're going to take the bottom one. Negative 10x minus 20y equals 30. We're going to plug in 1 for x, solve for y. Negative 10 minus 20y equals 30. Add 10, negative 20y equals 40. Divide by negative 20. We get y equals negative 2. That's 1, negative 2. Okay, we're going to go plug that back into the top equation, and we get negative 3 times 1 is negative 3. Negative 10 times negative 2 is positive 20. Negative 3 and positive 20 gives me positive 17. Again, we're kind of close. Ooh, this is a good one. So this is a nice one because we can multiply, we can find an equivalent equation for either one. If we want to cancel out my x's, so how am I going to cancel out my x's? Well, if I have negative 6, what's going to cancel out a negative 6x? A positive 6x. So I could multiply the top equation by a positive 3, which would give me a positive 6x, and my x's would cancel. Or if I wanted to get rid of my y's, I can multiply my bottom equation by a positive 2. I'm not doing both of them because that would be weird. It wouldn't give me an equivalent. We don't have to. We can do it efficiently by picking one. First, pick which variable do you want to cancel out, and then that will determine what you need to multiply the equivalency. So don't get confused in thinking you have to do both x and y, because we only want to cancel out one of the variables. So we're going to cancel out the x's. So I got to get rid of my negative 6x by creating an equation that has a positive 6x. That's why I'm multiplying by 3. I get my positive 6x. I get plus 18y equals 60. Most students will make a mistake here writing an equivalent equation because they didn't multiply everything by the 3. 3 times 2x is 6x. 3 times 6y gives me 18y. 3 times 20 is 60. And I'm just bringing my other equation. I don't have to manipulate it. I don't have to write an equivalency because my x's are going to cancel. I've done what I was hoping for, getting rid of one of the variables. And now I have 18y minus 3y, which is 15y equals 30. Divide by 15, divide by 15. Y equals 2. Let's pick an equation. I'm just going to pick the bottom one because it's closer. Negative 6x minus 3 times 2 equals negative 30. Negative 6x minus 6 equals negative 30. Add 6. Negative 6x equals negative 24. Divide both sides by negative 6. We get x equals 4. My solution is 4, 2, x comma y. And I'm going to plug it back into the top equation. 2 times 4 is 8. 6 times 2 is 12. 8 plus 12 is 20. We're having pretty good success. All right. Ooh, all right. So let's look at my x's. Well, what's a concern of mine is that both are negative. So I'm going to see, are my y's more conducive? Nope, because my y's are the same sign. So they're both positives. So it doesn't matter which one. I have a 9 and a 3. I have an 8 and a 2. So I'm going to manipulate the bottom equation. And I'm going to do the y's. So what's going to get rid of a positive 8y is a negative 8y. What do I have to multiply 2y to make it negative 8? Would be a negative 4. So that's how I'm going about my thinking. That's the process that I'm going through. This equation stays the same. And now I'm going to write an equivalency by multiplying everything by negative 4. That gives me positive 12x. That gives me negative 8y. And this gives me negative 8. Notice my y's cancel. And I get 3x equals 6. Divide by 3, x equals 2. Pick an equation. I'm going to pick the bottom one again. Plug in 2 for x. Negative 6 plus 2y equals 2. Add 6. 2y equals 8. Divide by 2. And we get y equals 4. So my equation is 2, 4, or my solution is 2, 4. Let's check it with the other one. Negative 9 times 2 is negative 18. 8 times 4 is 32. 32 and 18. 32 and 18 gives me 4. 14. 3 minus 1. I had to borrow from the 3 to make 2 minus 1, which is 1. So that worked. We are on number 28. Ooh, here we are. All right, I don't mind the x's because they are opposite of each other. I wouldn't choose to manipulate the y's because the signs are the same. So I like the fact that my x's, one's positive, one's negative. But notice there's no multiple of 3 that equals 4. And there's no multiple of 2 that equals 7 if we chose the y's, but I'm still choosing the x's. So I have to find a common multiple of each other. So what is a common multiple of 3 and 4? Well, 24. Okay. We could also do 12. We could do 60. But let's pick the least common multiple. It's always best. You can still choose any number, but let's pick 12. So we ask 3 times what is 12? 3 times 4 is 12. And negative 4 times what is negative 12? Remember, they have to be opposite values of each other. So that's going to give me positive 12x. The bottom one's going to give me negative 12x. So when I create these equations, remember to multiply everything. 12x plus 28y equals negative 52. 52? 52. Multiply everything by positive 3 gives me negative 12x plus 6y equals negative 84. Negative 84. I'm doing this in my head, so I may be incorrect. That's why we're going to check. 12, 14, 34y equals negative 136. Divide by 34. Divide by 34. We got some big numbers here. So 4 times? 34 times 4, 16, 12, 13. Yes. So this gives me negative 4. Pick an equation. I'm going to pick the bottom one just because it's closest. Plug in my y value. Negative 4x minus 8 equals negative 28. Add 8. Negative 4x equals negative 20. Divide by negative 4. X equals 5. 5, negative 4. Go in and test it. I'm going to test the top equation. 3 times 5 is 15. 7 times negative 4 is negative 28. Negative 28 and 15 gives me negative 13. And that does check correctly. 5, negative 4. Again, oh, so this one's okay. I like this. I'm looking at my x's. They're aligned. X, y equals constant. That's also really important. We got to make sure that's my first test. Now, I can choose either getting rid of my x's or my y's because both of those sets of coefficients are opposite of each other. And I'm going to pick the x's. So 6 and 10. What is the least common multiple of 6 and 10 is 30. So negative 10 times 3 would be negative 30, and 6 times what would give me 35? So 6 times 5 would give me my positive 30. So 3 times negative 10x is negative 30x. 3 times 4y gives me 12y. 3 times negative 30 is negative 90. Now I'm multiplying the bottom equation by 5. That gives me my positive 30x. Negative 3y times 5 is negative 15y. And 5 times 15, 25, 75. My x's cancel out. My y's give me negative 3y. And negative 90 and 75 is negative 15. Divide by negative 3. Y equals positive 5. Pick an equation. Pick the bottom one. Plug in my y value. 6x minus 15 equals 15. Let's add 15. 6x equals 30. Divide by 6, divide by 6. And I get x equals 5. So my solution is going to be 5, 5. Plug it into the top equation. Negative 10 times 5 is negative 50. 4 times 5 is 20, negative 50, and positive 20 is negative 30. That worked. Okay. I'm going to get rid of the y's because my coefficients are opposite. So again, I'm going to pick, well, let's pick 60. Let's just take the opposite, right? 10 and 6. So that's 70x. I didn't choose the LCM. I just chose a common multiple. 60 is not the LCM of those two numbers. But I'm going to show you that it still works. Equals 0. And that's 24x minus 60y equals 0. We just get bigger numbers. That's really the only issue with not picking the least common multiple. 4x minus 10y equals 0. 4 times 0 minus 10y equals 0. 0 minus 10y equals 0. Negative 10y equals 0. Divide by negative 10. We get y equals 0. So my solution is going to be 0, 0. I love when it's 0, 0. So if we plug it into the top equation, 7 times 0 is 0. 6 times 0 is 0. 0 plus 0 equals 0. And yes, 0 equals 0. Whoa. All right. So there's multiple things going on here. First of all, we have fractions. Blech. Second of all, they're not aligned properly. They're not in the same order. So I'm going to align it a little bit. I'm going to make sure that it's constant equals variable y plus my x. So I'm going to change this equation. I'm going to move my x value over to the right side. So it looks like this one. So that's going to make negative 4 equals negative 8y plus 6x. I can't just move it over by writing negative 6x. We move it over by adding 6x. We get rid of it on the left side. So that's why this equation is plus 6x. So let's just show that step, because I see too many students just moving just to move. You have to mathematically move it. How do I get rid of it on the left side? By adding 6x. And negative 6x positive 6x gives us negative 4 minus 8y plus 6x, because I want it in the same format. Now, that fixed that equation. Now, I don't like the fractions, So what's going to get rid of the fractions? We'll look at the denominators. There's a 3 in the denominator, a 3 in the denominator. So if I multiply everything by 3, that gives me -9 equals -5y plus 7x. Okay, Mr. Mac, that got rid of the fractions. Can I cancel? Can I add these two? No. So I still got some work. All I did was I was able to get them into the same format and nice workable numbers. So now I have to choose which variable do I want to cancel. Do I want to cancel the y's or the x's? It doesn't matter because the y's have both are negative and my x's are both positive. So I'm going to have to do some major manipulating. Let's pick the y's. Let's get rid of the y's. So they need to be opposite of each other. So if I multiply the top by +5, that would give me -40y. And how do I get +40y? Is by multiplying the bottom by -8. So I'm recreating equations again. So this is a major double. So let's write the equivalent, see, to that by multiplying everything on the top equation by 5. That gives me -20 equals -40y plus 30x. Let's multiply that bottom equation by -8. That gives me +72. That gives me +40y. And that gives me -56x. Okay, that worked because we notice my y's cancel out. That's going to give me, if I add my other column, that's going to give me 52 equals 56 and 30, signs are different, 6, 26. X, good. Oh, -26. I had more negatives than positives. Mr. Mac almost made a mistake. I checked before I did. -26. -26 gives me -2 equals x. Let's pick an equation. I definitely don't want to pick the bottom one. -4 minus 6x equals -8y. I'm saying that my x value is -2. -2. That's -4 plus 12 equals -8y. That's going to give me 8 equals -8y. Divide by -8. -1 equals y. So my answer is going to be -2, -1. -2, -1. Let's plug it into this one. -2, -1. All right, we're going to have to check down here. So my equation is -3 equals -5/3 y, -5/3 y, plus 7/3 x, plus 7/3 x. And I'm plugging in -1 for y and -2 for x. Okay, so I get -3 equals +5/3. These are going to cancel, -7. Oh, Mr. Mac made a mistake somewhere. So we like this. Right? 5/3, -21/3, which gives me -16/3, does not equal -3. So I know my answer is wrong, even though I may have made a mistake somewhere else. So I think I made a mistake somewhere. Oh, I see where I made a mistake. I canceled the 2, but it was a 3. All right, so I didn't make a mistake. I just made a mistake in my check, which can happen also. So we get negative 3. That negative 5/3 times negative 1 gives me 5/3. These don't cancel. This is negative 2. This gives me negative 14/3. And 5/3 minus 14/3 gives me negative 9/3. And negative 9/3 is equal to negative 3. So my answer is correct. Negative 2, negative 1. Let's write that negative 1 a little bit better. That was a tricky one. Whoa. All right, 32. Is that the last one? Yeah, it is. Last one. So let's put them in the same order. Oh, they're in the same order. I have my constant. I have my y's, and then it equals my x's. So we're good there. Now we just have to pick a variable to cancel. I'm going to cancel my y's. So let's find the LCM of 6 and 8, which is 24. I like because they're opposite of each other. Remember, that's a nice thing. So if I multiply 8 times 3, that gives me 24. If I multiply negative 6 times 4, that gives me negative 24. So 3 times 1 is 3. 3 times 8y is 24y. 3 times 7x is 21x. 4 times 12 is 48. 4 times negative 6 is negative 24y. 4 times negative 18, I don't know. 32, 72, negative 72x. My y's are going to cancel out. My constants give me 51 equals negative 72 and positive 21 is 51, negative 51x. Divide by negative 51, divide by negative 51, negative 1 equals x. Let's pick the bottom equation. We're going to plug in for x, which is negative 1. 12 minus 6y equals positive 18. Minus 12 minus 12. Negative 6y equals positive 6. Divide by negative 6, divide by negative 6, y equals negative 1. My solution is negative 1, negative 1. Let's test it. 1 plus 8 times negative 1 is negative 8. 7 times negative 1 is negative 7. Does 1 minus 8 equal negative 7? It does. These are all the answers. We are done. It'll be interesting to see how long this video is. It felt like an hour. Good luck. Enjoy.